In this video, we're going to solve a very interesting integration problem using two substitutions. Coming right up. Hi, this is Ash with Math Hero Academy, bringing you this gem of a puzzle from the Putnam exams in the 1980s. So here you're asked to evaluate the definite integral from 0 to infinity of t power minus half e power minus 2019, which is this current here, multiplied by t plus t power minus 1 dt, and you're given this well-known identity minus infinity to plus infinity of e power minus v squared dv to be equal to square root of pi. We're going to solve this in 3 steps, and it's going to have 3 hints. The first hint is going to be a hint for you to solve. It's going to be quite difficult. See if you can solve it, and then we're going to provide another hint, and then towards the end we're going to provide a simpler hint, after which many of you will be able to solve it. So let's get started. So we're going to solve this definite integral, and it's quite a hard problem to solve. The first hint that I will give you is to break up this integral into 2 parts. So we're going to write this down as integral of this whole thing inside from 0 to 1 of this whole thing inside, plus the integral of this whole thing inside from 1 to infinity. And so we're just going to copy this whole thing over here. Got a t power minus half e minus a t plus dt. And here we're going to copy down this exact same thing, but we're going to use a u substitution here. We're going to substitute u is equal to 1 divided by t. I think this hint is very important. Now see if you can somehow combine this hint with this integral and simplify your expression. See you soon. Hopefully you were able to have some idea what you could do with this expression. You have u is equal to 1 divided by t, and now let's take the differential form. Du will be equal to minus 1 divided by t squared dt. And now we're gonna plug everything inside over here, but before that let's just write down, we've got t power minus half dt here, so let's bring the t to the 3 divided by 2. Let's break this down as minus 1 t3 divided by 2 dt times t half. And now this part and this part are right over here, and this remaining piece, let's move it here. So you're going to get t minus t3 by 2 du is equal to this right hand side, which is dt t power minus half. And now because we know u is equal to 1 divided by t, we just write this as negative du u power minus 3 by 2 is equal to this right hand term. Now let's plug this inside over here. Got a negative sign, then we've got u power minus 3 divided by 2 e power minus a. And note here the t will become a 1 divided by u, so you write it as u minus 1, and this t inverse will become a u just because you're using this substitution, and then this t power minus half dt will be equal to, of course, du. So t power minus half dt is u power minus 3 divided by 2 times du, and then we're just copying this down. But note that what you're doing here is you're going from 0, instead of 0, now you're going to need to change your limit of integration from infinity here because you got u is equal to 1 by t, and this becomes, and this stays as 1. And now you got a negative sign integrating from infinity to 1, which we can just write it as a positive sign integrating from 1 to infinity. And now, fortunately, we've got this 1 to infinity and 1 to infinity, and so we can combine these two terms together. But let's write both of these internal variables as some other variable. So let's write this whole expression as 1 to infinity u power minus 3 by 2. And we can combine this expression, these two expressions. It doesn't really matter you've got a t or a u. These are just variables that need to be integrated. So we can just write this also as u. So we can write this as u power minus 3 divided by 2 plus, we're going to add this guy. We've got u power minus half. And then note we've got everything same over here. So we've got minus 8 times u power minus 1 plus u du. If this step is not clear, write it down in the comments and I'll explain it a little bit better. So this is the second hint for you. Once you've got this expression, go ahead and see if you can solve this expression now. This is a much easier expression to solve. Know that you've got this thing in the bracket here and you've got a du. So let's find something which, when differentiated, is going to give us this whole piece plus this. And the answer to that will be u power half minus u power minus half. And let's assign that to be v. Now let's use a constant as well, a power half. It'll make our lives easier. And let's differentiate this on both sides. We've got a power half times half u power minus half plus half u power minus 3 divided by 2 here. If it's not clear, just type over in the comments and I'll make this clearer. And that is going to be equal to dv. Now let's move this half to the other side. So we're just going to write it 2 dv here. And we're going to have an a power minus half, or square root of a right over here. So we can cancel out this a and this half. And now you can note this expression here, u power minus 3 divided by 2 plus u power minus half times du is right inside over here. And so we can substitute all of this with just 2 dv divided by square root of a. So we've got dv here, and we're just going to write down 2 divided by square root of a right over here. And now when we square this term, we're going to get something that's inside here. So let's just square this quickly. A power half squared is just going to be a, and then when you square this section here, you're going to get a minus b squared, which is a squared, and that's u, plus b squared, so that's going to be u power minus half, and then you got a squared plus b squared minus 2ab, and that minus 2ab is just going to be minus 2 times this, and that is 1, so you get a negative 2 here, and it's equal to v squared. Now let's bring this minus 2a to the other side. So we brought this 2a to the other side now, and we can substitute a times u plus u power minus 1 right over here. Instead of that, we plug in v squared plus 2a. And now we're pretty much done. Let's just change these limits of integration. Remember this the bottom one, will have the value of v, which is 1 power half minus 1 power minus half. So this will go to 0, and so this lower bound will be 0 now, just because we've changed the variable here from u to v. And the infinity will be infinity power half minus infinity of negative half. So it's just infinity half plus negative infinity minus infinity. So it's just going to be still infinity, because you've got infinity power half minus infinity power minus half, and this guy goes to 0 because infinity power minus half is just close to 0. So you're just going to have an infinity sign here. And so you're left with integrating this part. And this is where you use the second part of the problem, where the integration of negative infinity to plus infinity of e power minus v squared dv is equal to square root of pi. So we can break this down as e power minus v squared times e power minus 2a times dv, and just bring this e power minus 2a outside. And this 2, remember now we've just got e power minus v squared, so let's just cancel this out. And since we've got a 2 here, and from 0 to infinity we can cancel this 2 out and write it from negative infinity to plus infinity, because this function is symmetric over positive and negative numbers. And so we can have negative infinity to plus infinity of e power minus v squared dv is equal to square root of pi. And so all of this piece here is just square root of pi. So let's write that down. And so this is going to be our final answer, e power minus 2a divided by square root of a times square root of pi. Let's summarize this problem one more time. We had an integral from 0 to infinity, which we broke as 0 to 1 plus 1 to infinity. And then we substituted whatever was inside. We substituted tu to be 1 divided by t. And so this integral became, the bounds became from infinity to 1, and you have a negative sign somehow because of the substitution, and so we reverse this to get 1 to infinity. And so we actually had a 1 to infinity plus a 1 to infinity, which we then added these terms together to get something like a u power minus half plus u power minus 3 divided by 2 kind of integral, which had an e power as well over here. And now we substituted another value so that this piece times this would give us that differential form, and that answer was u power half minus u power minus half to be equal to another variable u, and then another variable v, and then we eventually obtained something to the order of e power minus v squared dv from minus infinity to plus infinity. So doing all of this mess, all we needed was to arrive at this answer, and this we know to be equal to square root of pi, and this is actually going to be a power half here. Okay, hopefully you like this solution. Don't forget to like and subscribe to this channel. Talk to you very soon. Bye.